check, check, check. And I can align everything, right? Pretty nifty, huh? And then from here on, we don't have to think about this stuff. It just kind of goes. Oh, all right. How you doing? How's your last week?
Good.
Yeah.
We went to school today for 4 periods.
Okay.
It was really weird. The first
Because you haven't been in a minute? Are you 16 yet, officially?
In, I think, 16 days.
Oh, okay, so you still have half of November.
So then, after I turn 16, I'm fully enrolling and starting to work on my high set.
Okay.
Yeah.
High set. Also, sorry I had to do this to you.
Oh my god.
That's just a practice test.
Oh.
This is what the high set's gonna look like. That's language arts. So we're not gonna tutor language arts. But I printed out everything for you because I had it.
Mm-hmm.
And I figured this would be a good starting place for you before studying would be to just take a test and see where you lie. Right? And if you get a passing score right away, that's a confidence booster. And if you don't, then we just work on strategies for what sections, because it wouldn't be like every section that you would either pass or not pass. It would probably be a mix of the two. This is obviously what we're going to focus on today. So you can put that in your little storage backpack or whatever it is.
Also didn't bring a pencil.
What was that?
I didn't bring a pencil.
Oh, I think I got it for you. Why was it weird? Just because people were expecting you to not be at school, or just because you haven't been in a while?
Just because I haven't been in a while. And I only really went to one actual class.
Biology.
Yeah.
Of course. And it was fun.
Yeah. It felt normal.
Do you get to keep going? I forget we talked about this. Do you get to keep going to that?
Yeah.
Once you're out of school?
Mm-hmm.
That's the only one though, right?
Yeah.
Good. And are you even getting a grade for that?
I think so.
Okay.
But the counselor told that teacher to not worry about any past assignments and just teach me what's happening right now.
Cool.
Which is good because I don't have to catch up.
Yeah. And biology doesn't quite. Yeah, it does. It doesn't fully build on itself like math does.
Yeah.
Like if you miss the first half of math, you're just going to be using those tools for the last semester.
Yeah.
Biology does have that, but it also has a lot of kind of independent sections. So you'll probably, especially if you're interested, you'll be just fine. All right, so this is 2017 high set. Obviously, it could have been updated in the style of questions that they're asking, but I have access to 2017 and back is what they released for free. And if we look at some of these questions, do those look like math questions to you? Mm-hmm. Yeah, they're probably not going to be too different on modern high set. And this is actually released on high set's website. It's not like made up by some random person. And there's a lot of different kind of topics going on here. We have a formula sheet. We've got problems that kind of jump from topic to topic or skill to skill as you go through. Mm-hmm. What I'll be teaching you in terms of test prep is how to kind of navigate your way through a test. And let me assume, when you go through a test, you start with problem 1. Mm-hmm. And then you move on to problem 2. And then 3. Then you get stuck on 3, and you spend 5 minutes on it, and then you just guess, then you move on to 4.
Yeah.
Something like that?
Yeah, or I just skip that one and go back to it.
Honestly, better than most students. Because a lot of students will get so stuck on a problem and get frustrated by it that they're wasting their time, and they end up guessing anyway. You know who knows that? Test creators.
Yeah.
So a lot of tests will start with like 2 or 3 easy problems, and then throw a tricky one in there that will catch up students who aren't willing to skip and move on. Mm-hmm. We're going to talk about the strategy, not right now today, but eventually about the strategy of going through one time and going through question by question and marking them with basically a plus or minus, or if you ski, like a green circle, blue square, black diamond, basically just telling yourself, hey, once I go through all these and mark them up, I'm going to go back and just do the easy ones to start. And then I'll go back again and then do the medium ones. And then if I have time, I'll go back and do the hard ones. And that's going to save you a lot of time. And what it's going to do is allow you to kind of group questions by their subject, because those 2 questions have nothing to do with each other. Mm-hmm. And those 2 questions have nothing to do with each other. But this question and this question, percent and percent, and then questions with graphs, they have more to do with each other. So you'll kind of be grouping that way. Mm-hmm. For today, I think maybe you just go through this and let's just star like 3 problems that seem like problems you should be able to do, but you're not quite sure how to do. And you can just take a couple minutes to kind of go through the packet and literally just pick out like 3 questions that you're like, these are the ones I want to talk about today.
Okay.
And that'll be that to start. And I'm gonna get my water. I'm just going to kind of write them down as you go through it here. Classic. It's a classic problem. So every time you see an x squared, you're like, alarm bells are going off in your head.
I think I need to like use.
That's fine. You're gonna be just fine. Okay, got that one. All right, in a graph. We'll start there. Don't get overwhelmed. It's gonna be just fine. We'll just come back. Let's do these other 2 first. They're pretty symbolic. I already have them written down. And then with the tools that we learned in that, maybe we can come back and visit the graph question. Okay, now, this first question looks a little bit like the second question. This one's asking us for the zeros of this function. And then the other question is asking us for the sum.
Mm-hmm.
Okay, so the zeros, that might be a word that some math students are like, I don't really feel good about that. But what is a sum?
Answer.
It's an answer of when you do like what, subtraction or multiplication or...
Is it an addition?
It's an addition, right? A sum is just adding 2 things together. Probably an easier place to start, so I'm going to scroll over to that here. We've got the term 5x squared plus 3x minus 7 plus, or the sum of, the next function, which is 12x plus 12. So this right here looks just like what's written on your paper,
Mm-hmm.
more or less, right? I just replaced a plus sign with the word sum of.
Mm-hmm.
Do you notice, obviously if we were doing this problem, if I covered the 12x, all the x's, and we just had -7 plus 12. If you're in debt $7 and then you make $12, how much money do you have when it's all said and done? $5, right? So you know how to add whole numbers together, right? Even with negatives, which can sometimes be tricky. Essentially, that's what we're doing. In fact, check this out. I'm going to use the power of my iPad here. And I'm not going to change the problem whatsoever. I'm just going to move it around to stack it on top of each other. Okay, there we go. And then I accidentally took some of my equal sign, but that's okay. I'll just erase that. All right. So now I have the same exact problem written down. And the trick that you taught me, I'm not going to forget about it. Look at that. All right. So -7 and 12, what did we just say that equals?
5.
5. Okay, cool. So we got that. Positive 5 or negative 5?
Positive.
Sure. You kind of came out of debt. Okay, look at this. You were in debt, and then you came out of it and actually came out on top. I like this little laser tool. Same exact idea here. Just know that when you add these two numbers together, they're going to include an x.
So 15.
15x. Right? An x could be anything. It could be a number, or it could be representing some object or some measurement. But we know that it's the same x here as it is here. So when you add 3 of these x's to 12 more of the same x's, you're going to end up with 15 x's, right? And if x's were cat faces, you'd end up with 15 cat faces instead, right? It's just, we're choosing to use x because mathematicians are boring and non-creative and whatever. All right, and then here's one more. In fact, let me do this really quick. I'm just going to expand this out so it looks just exactly like the top one, and I'm just going to add 0x squared.
So 5x squared.
It's still just 5x squared, right? And just to be sure, was this 15 before, or was that positive or negative?
Positive.
Yeah, it was positive. And the 5 was also positive. Do we need to write a plus sign out in the very front of everything? That's just assumed. Voila. Sylvia, you did it.
A.
Right? Yeah, and I guess we can translate that to some answer they give us. But if it was a fill in the answer, we still would have gotten it. Right. Okay, before we move on to the next one, let me just follow that up by doing this. I'm going to go.
Do I have to write that down on the paper?
Well, I'm going to have you actually just do another problem just like that. I'm going to make it up with some new terms, and you can just try it again. And I can take this guy and just make it tiny and put it in the corner for reference in case you need it. So I will give you this problem here. How about negative 3x squared plus 7x. Actually, you know what? I'm over x's. Pick a new letter or symbol. I don't care. Whatever you want. Smiley face. A letter. Smiley face. Okay, so we have 3 smiley faces. There we go. We're going to squared. We're going to add to that, so that's like a smiley face times a smiley face. And add to that 7 smiley faces. X's, whatever you want to call them. Minus 10 units of not smiley face. And then we're going to add to that, how about a single smiley face squared minus 2 smiley faces plus 5. Okay, and then we'll just, I think it'll let me do this. Maybe? There we go. All right, and I will let you even pick your color. Try drawing better smiley faces than me, to the best of your ability. That's right on par with mine, I think. It's okay. We're in this together.
I keep thinking it's 30.
Yeah, yes. Maybe this is why mathematicians don't use smiley faces on the regular, but that's okay.
Oh, I thought that was 10. Wouldn't that just be negative 2?
I think it would be. Boom. There it is. Okay. You want to see one quick magic trick? Let's see. I do have a calculator on here, but I think I'm just going to do it on my phone. All right. Pick a number for smiley face.
3.
No, we don't have to do it on the phone because I can do this. Watch this magic trick. So we're going to pick 3. We're going to pick smiley face equals 3. Okay, and I'm just going to run this through really quick. So we'll do negative 3 times 3 squared, so just plugging in for smiley face, plus 7 times 3 in this case, minus 10, plus 1 smiley face squared, so that's another 3 squared. So I'm doing the top here. I'm going to keep going, minus 2 times 3, right? And then, yeah, that's coming from here, and then on to the last one, which is plus a 5. Okay, what is 3 squared, or 3 times 3?
9.
9. So we have negative 3 equals times 9 plus 7 times 3? 21 minus 10. Again, 3 times 3, or 3 squared?
9.
9. Okay, we're going to do the exponent first before doing the multiplication out front. Plus 1 times 9, which is pretty easy. That's just a 9. We'll get there. 2 times 3? 6. And I just automatically put a negative there because I've been doing math for so long, it's easy for me to think. Negative 2 times 3 is negative 6. Or you could think of this as minus 2 times 3. Either way, it's going to come out to be a minus 6 there. And then plus a 5. All right, we'll just go quick with this one more time. 9 times 3?
27.
27, and it's a negative 27 in this case. And then plus 21, minus 10, 1 times 9, minus 6, plus 5. Okay, I could do this in my head, but I don't even know how to, they updated my calculator, now it looks all different. I don't even know how to do negatives. Negative 27 plus 21 minus 10 plus 9 minus 6 plus 5 equals negative 8. Okay, where am I getting with this? Not there yet. That's what all of this equals to.
Oh, okay.
If smiley face specifically equals 3.
Yeah.
So if smiley face still equals 3, and I plug it into the purple equation, what should my final answer be?
Negative 8.
It should be negative 8. Let's just check it really quick. Okay, I don't have any more room, but I do have the magic of technology. And we're just going to do this. Just a little smaller. God, I wish I could do that on a whiteboard. Make teaching so much easier. And then I'm going to pick our nice purple pink color here. So negative 2, same value, negative 2 times 3 squared plus 5 times 3 minus 5. Okay, what are we going to do first? Negative 2 times 3 or 3 times 3?
3 times 3.
3 times 3, which is 9 again. 2 times 9 plus, okay, 5 times 3?
15.
15 minus 5. Negative 2 times 9, one more time here.
8, negative 18.
Negative 18 plus 15 minus 5. All right. There's a couple ways to go about doing when you have a couple negatives here. You could smush the negatives together. You could do these two first. You could do these two first. Whatever's easiest to you. What is negative $18? And then you add to that positive $15.
30.
That's going to be, right, you're more in debt and you don't quite make back your whole debt.
Mm-hmm.
So it is 3, but it is negative 3. And then what's negative 3 minus 5?
Negative 8.
Negative 8, right? Down $3, down another $5. Mm-hmm. You're now down $8, just like we expected, right? So we know we did our addition right because we tested a number.
Yeah.
Okay, and you can do that with any number because this purple expression is no different than the sum of these two expressions. Mm-hmm. It's just a simplified version.
Yeah.
And if you were a mathematician that had to use this equation a million times over, which one would you use? The purple one?
Yeah.
Just because it's simpler, right?
Mm-hmm.
Cool. All right, that's that. Let's do, we're doing good on time. It's only 4:18. Let me just show you. So smiley faces are great, and I love doing variables that aren't x's. But let me just show you when, like, it might be kind of cool to think of it in terms of x's. I'm just going to do another quick one here. We'll keep it to positives to make it extra clear. And then we'll add to that. I don't know. Give me numbers from 1 to 5.
3.
3.
4.
4 again. And
1.
1. Okay, cool. So we could be quick with it. You know, just use your voice here. What's 2x squared and 3x squared make?
5x squared.
5x squared. In fact, I'll just write this answer down because we're already getting so good at this. What does 4x and 4x make?
8x.
8x. And then what's 2 and 1 make?
3.
3. Okay, so we know that's going to be our answer, but allow me to just visualize this one time so you can see why x squared do not add with x's and why x's do not add with whole numbers here. So for this top equation, let me break it out just a little bit. Oh, I accidentally took looks like I took 1x from 4. There we go. That's not how you do subtraction. Right. So kind of broken it down a little bit here. I'm going to draw 2x. Actually, I'm going to start with 2. I'm just going to draw 2. So here's 1. Here's 2. Those are teeny tiny, right? Those are lines of length 1. They kind of fit into one of those boxes. So each of those, that's a 1, and that's a 1. In fact, they don't need to be the exact size of the box. We can call anything we want 1, as long as we're clear. There's 1. In fact, we'll do vertical. Doesn't matter. Same line. Standing up on its legs there. So there's a line of length 1 and a line of length 1. Okay, that's the 2, and then we're going to add to that 4 x's. Now, could x be equal to 1?
Yes.
In some cases.
Maybe.
Right? But could it also not be equal to 1? So I don't know what x is, but I am going to draw it longer than 1. I'm not saying it is definitely a number bigger than 1. I'm just saying that it's, unknown. And in fact, we have 4 of them, so I'll take that last x away and just draw 4 of these lines. Okay, those are not perfectly equal in length, but I think we're going to be okay, huh? I'll redo the last one. That was the bad one. There we go. Okay, so these are each length x. These are each length 1. And then the one that the reason I'm showing you this, the one that students don't really think about too often is, and this is a crappy plus sign. Let's try that again. We'll do a different color. Plus, and then plus here. iPad's giving me too much power, right? Okay, now we need to have 2x squareds. So this is x, right? So I can actually take this x right here, and I'm just going to copy it, paste it. Maybe. You don't let me paste? There it is. Okay, there's my x, and then I'm just going to paste it again, and I'm going to make x squared. So x by x, that's the wrong color. So this is length x by length x. When you multiply 2 x's together, you're making a square that's area is x squared. That's where the word square comes from. Yeah. Right? Base times height, that's a multiplication. X times x, it's the area of the square. It's x squared. And we have more than one of them, right? Yeah. We have 2 of them. So now I'm realizing I could have made that much smaller. Okay, and I'm just going to very quickly do this. It'll let me. All right, here's my 2x squareds. So I have 2x squareds, 4 x's, and 2 1s. And of course, my bottom one isn't going to look quite as good, but I'll add one more 1. Okay, I'm going to add 4 more x's. 1, 2, 3, 4. And then I'm going to add 3 more x squareds. Told you it wasn't going to look as good. I think if I hold it down on a square shape, I literally have to draw something that even kind of resembles a square. And then it'll recognize it. There we go. All right. What was our answer again?
5x squared.
How many squares do you see?
5.
Cool.
8.
8x, how many of these x lines do you see?
8.
8, and then how many of the ones do you see? 3. Again, x could represent anything, but if you're talking measurements, the reason you can't, this is going to get a little spaced out in like physics-y, but the reason you can't combine x squareds and x's is because x squared lives inside 2 dimensions, and x lives inside 1 dimension. And if you've ever been curious what x cubed looks like, well, it looks just like x squared, x by x, but then you add a 3rd dimension that is also length x, and you get yourself a nice cube that is volume x cubed, x by x by x. And can you add cubes to squares? No, you have to live in some weird interdimensional land where dimensions can just play together all kind of neatly. But in math, this is why they say combine like terms. What they really mean is combine terms that exist in the same dimension, the same space. That's like level here for when you would first teach this, but I like the visual because otherwise it just seems like a rule that a math teacher tells you and you're like, okay, why can't I put the 2 and the 4 together? They both have x's or whatever. Okay. Do you think you understand the sum one pretty well? All right, we got this. Zeros of the function is going to be a little different, a little trickier. I still have that problem actually hiding out over here. What I'm going to do is I'm going to solve it 2 different ways for you just right away, and then we'll come up with a new problem, and then you can work on solving that one. Okay, the first way is called factoring. You heard that? And have you heard FOIL? Like distribution, when you do like the front times the front, and then the front times the last, and the last times the front, last times. That FOIL, front, outside, inside, last, is just the opposite direction of factoring. So we're actually going to be turning this equation here into an equivalent equation, but it's going to be in this form. Instead of plus signs separating the terms, we'll have terms inside these 2 sets of parentheses, and the terms will be multiplied together. There's a reason we do that. It's actually really helpful, because when we're looking for what's called the zeros, what we're really looking for is when the y value, or the function value, is equal to 0. So we just know that f of x is going to be 0. Okay, and just so you can see, we can do a little preview to the next graph here. None of these have zeros shown on them, because do any of these cross down through the x-axis? Not quite. The 0 is when y equals 0. It's not positive, it's not negative. It's when the line crosses the x-axis, because that right there is when y equals 0. Yeah. Okay, and that seems like not very helpful unless you're like doing anything at all ever in engineering. Finding the zeros of functions tells you, or in calculus, it tells you how high up a projectile can get, or the maximum like pressure that a vessel can withstand, or it typically happens at intersection points on the graphs. Really important information. They're giving you a more abstract problem to work with here, but I promise you this is super helpful. Again, I'm just going to show it to you one time, and then we'll step through kind of the process. I know I'm going to have an x and an x in front, because when I multiply front times front, what does x times x give me? X squared, right? We were just talking about that. And that's this term right here. So because I know I'm going to need this term, I know I'm going to have an x times an x in front. So whenever you get a problem that says find the zeros, this is almost always your initial setup. 0 equals 2 sets of parentheses that are multiplied by each other with x's in front. That's if you have an x squared right there, which you will on high set type problems. Okay. The other one I like to look at is this 24, negative 24. Because when I do my last term times my last term, and if these are each just whole numbers, then the only whole number that's going to show up in my answer here is the product of one whole number with the other whole number. It's like 20% makes sense, but we're going to step through it. Negative 24 can be written using a handful of factors. What two numbers can you multiply together to make 24? There's a couple
12
sets.
and 2.
12 and 2. That's one of them. One of the sets. What else?
6 and 4.
6 and 4. Exactly. I made it look like 1 and 1, huh? It's not 1. It's supposed to be an arrow. Okay. And there's actually one more common one that we could use.
And 6.
All right, we got that one. You're good. There's a number in between 6 and 12 that also goes into 24.
8.
Yeah, 8.
8 times 3.
8 times 3. And technically, 24 and 1 is also a set of factors, right? But here we go. We now have our factors. So no matter which factor I choose, we'll just start with 12 and 2. If I put 12 in here and a 2 in here, and I multiply, again, my front terms are going to give me x squared. That's great. My last terms are going to give me 24. It doesn't matter if I use 12 and 2, 6 and 4, or 8 and 3. I will get 24. But what does matter in picking between these options?
Which one's negative?
That is a very good point. We're definitely going to have to incorporate a negative. One of these is going to be negative and one of these is going to be positive. Maybe it's this way. Because we know we're going to have to get negative 24. So that's a really important point, and we're going to come back to that. But another thing that we have to think about is how do we get the 2x? How do we get the 2x? And there's a process for this that will probably become clear when we step back through this in reverse order. But I'm going to give you a little hint for now. And the hint is basically you need to be able to make a 2 using a positive and a negative of one of these sets of numbers. So you need to, in any way you can, be able to make a 2 using a 12 and a 2. Now, can you add or subtract 12 and 2 to make a 2? Not quite, right? So that one's out.
6 and 4.
6 and 4. That's, I didn't have to lead you on, right? 6 and 4 can combine to make 2, right? A positive 2. So is it positive 6 minus 4 or negative 6 plus 4?
Negative 4 plus 6.
Negative 4 plus 6. So let me just erase these back. Oops, that's the highlighter. Don't want to highlight. And we'll just do, like you just said, how about a negative 4 here and a positive 6 here. Okay, this is what I'm going to do. We're almost to the answer, but in classic teacher fashion, I'm not going to just skip right to the answer because I want to keep talking. Right? Because teachers like to hear themselves talk, huh? You're like, yeah. All right. If I just wanted to check myself really quick, I could just do front, outside, the inside values, and the last values. That's what FOIL stands for. Another way to think about FOIL is just multiply each term by every other term in that set of parentheses. So I'm going to do my x by the x and the negative 4. And then I'm going to do my 6 by the x and the negative 4. So just multiply every term in the first parentheses with every term in the second parentheses. If that helps you remember that, great. Moral of the story is, what is x times x one more time?
X squared.
X squared. What is x times negative 4?
2. No.
It's kind of weird.
Negative 20. Well.
And we're just doing negative 4 times x. Negative 4x, right? When we write
6 and 4.
Oh, sorry. I probably pointed in a weird spot. So negative 4 and x makes negative 4x. Because when you write that, what you're actually implying is negative 4 times x.
Yeah.
Which, pretty cool that the answer to negative 4 times x is negative 4 times x.
Yeah.
You can't combine x's and 4's because we don't know the value of x. So we can't push them together quite yet. Now let's do the 6 and the x. What is 6 times x?
6x.
Right, it's positive, right? And then finally, what is 6 times negative 4?
Negative 24.
We better hope so, huh? Because that's how we deduce the 6 and the 4 in the first place. So you see why we were able to figure out that it started with an x and an x, because we got our x squared here. And then we also picked a factors of 24 so that we could make 24. We also knew that there was going to be a plus sign and a minus sign, because multiplying two numbers together, if you want to get a negative answer, you're going to have to multiply a positive by a negative. So far, so good. And now you can really see why we picked the 4 and the 6, because what is positive 6x minus 4x?
2x.
2x. Now, this is me just backtracking, but what's the difference between this and this?
You know how you got that.
Yeah, we kind of, is it different? Or are these two things the same?
It's the same.
They're the same. So all I was showing you was that, I'm just going to take my big eraser here, was that when we factor it, we're doing the opposite of FOIL. You're actually breaking it into factors instead of combining the factors back into some standard form.
Yeah.
Okay? Now the beautiful thing about this form, why this form is so powerful, is because of one simple thought in math. What is 0 times anything?
0.
0. 0 of anything. 0, phones, $0, 0 tutors. It's 0 of those things. It's always going to be 0. Which means if we can make this equal 0, then it doesn't matter what this over here is equal to, because what is 0 times anything? 0. And then is the equation happy?
Yeah.
Yep. Okay. Or if we can make, what do you think? What I'm about to say here? What if we can make this one equal to 0? We can plug in some number for x to make this equal to 0. In fact, you could just probably think of it right now. What number can you plug into x to make this whole term equal to 0?
0.
0 minus 4 would be negative 4. So what number minus 4 equals 0? 4. If we were to plug in a 4 here, we would get 4 minus 4, which is 0. And we'd get 4 plus 6, which is 10. Whatever, it doesn't matter. Because what's 0 times 10?
0.
0. And is our equation happy now? All right. So you actually just found one of the zeros. You did it. Let me erase and write it just a little cleaner here. So
it's negative 6 and 4.
Yeah, you're pretty much onto it here. So we know that x minus 4,
Negative 4.
we want to make x minus 4 equals 0 for one of our answers, and we want to make x plus 6 equals 0 for another one of our answers. Okay, we know that for this one, the answer is x equals 4, and for this one, the answer is
Negative 6.
x equals negative 6. If you wanted to be really fancy about it, you could do that thing that math students do where they subtract 6 from both sides, cancel out, x equals negative 6. Or just use logic. I don't really care either way. And you know what? I know when I'm recording this screen, this is where our video is going to sit, which means that no one's going to be able to see that. So I'm going to hide it over here for a second. Cool. We got our two answers. So I can erase this for now. And I'm going to show you one more thing that's going to make you understand visually, which I like. So our two answers were x equals 4, comma, negative 6. Let me keep that boxed. If I plug in those values into this equation, I should hopefully still get a 0. I'm going to do one in my head just really quick. Okay, I'll do negative 6. Negative 6 times negative 6 is positive 36. Negative 6 times 2 is negative 12. So 36 minus 12 is 24. And what's 24 minus 24?
0.
0. Great. You can do the 4. What is 4 squared? 8. What is 2 times?
4.
4? Or no, you just said 8.
8.
You had me believing. What is 4 squared? What is 4 times 4?
16.
16. 4 times 4 is 16. What is 2 times 4?
8.
8. What's 16 plus 8? 24. What's 24 minus 24? 0, we got it. Okay. Let me do this really quick. So I don't have to keep going back and forth between screens. I got this app. And I think my screen will just continue to record. But you know what? I thought I had decimals, but we're going to go with GeoGebra. It's just as good. We do y equals the equation, which was x squared plus 2x minus 24. Okay. Can you tell me where this graph crosses the x-axis?
-6 and 4.
Crazy, right? That's what you saw. That's what you were solving for. You're essentially given the equation to this graph, and you could have plugged in a million trillion numbers until you plugged in the right one that gave you 0. Or you can like unravel the equation and just solve for where the 0 should be by literally forcing your equation to equal 0. And then it solves it for you, and then you don't have to actually graph it. But the graph will coincide with your answer if you did your work right. Or if you were in class and your teacher gave you a worksheet that made you solve 200 of these, you could type in all 200 equations into GeoGebra, and you could be like, okay, there's my first answer, there's my second answer, whatever, right? Technology's great. I'm okay if students use it to quote unquote cheat, just doing faster math. All right, let me give you one more of these that you can work on. And I promise you, it's not going to settle well the first time because this is one of the harder subjects that students have to learn in school. It's very abstract, a lot of steps to it. And most of the time, students don't even know why they're doing it. So if it takes some time, that's okay. Okay, we will pick, what I'm going to do actually, this is how teachers typically set up these problems. They literally write out the factored form of an equation, solve it. That's 5x minus 3x is 2x. Okay. And then they don't show the students this part. And they say this is equal to f of x. And they say find the zeros, when in reality they made it by already defining the zeros to begin with. So we're going to find the zeros by factoring. Okay, you're going to have, it's totally okay if you ask me 100 questions along the way, but you have control of the iPad now. I'm on Tutoring. Look at that. Okay, now you gotta actually find the zeros. You're close. Yeah. You've got it set up, and it's kind of one logic step away. Oh, and I erased it to make your life hard. Remember, it's okay if your hand rests on the screen. It won't pick up on your hand. Unless that's how you write it.
No, that's how I write.
I was going to say.
Maybe I put that in parentheses.
You're actually doing work right now to remove the parentheses from this. You're separating each individual factor, which is great. You're going to prove to yourself that you factored it right.
Oh, jeez.
What does 5x minus 3x equal?
2.
2x, right? And you can just rewrite the rest of this. Okay. You just proved to yourself that you definitely factored the original equation correctly, because when you FOILed it back, it went right back into its original form. So you didn't have any mishaps in your thinking, which is great to feel confident. And I showed that to you last time to also show that that's a way to check yourself, but it doesn't quite give you your answer. Actually, getting your answer is almost an easier step. So I'm going to do it for you really quick is I'm going to clean up these and these. I'm going to take this. I'm going to keep it because it's valuable, and a teacher would want to see this on students' work to say, hey, like, I did this right. Put it down here. I'll break it down, and how about looking like this? How about we do x minus 3 equals 0 and x plus 5 equals 0. So this is kind of like your little side note to think about, because if you remember, we're just trying to find some x value, some number that you can plug into x, so that this equation altogether will equal 0. We're trying to force that to happen. So what number can go into x to make one of those terms equal 0?
3.
3. There's one of them. So x equals 3 is an answer. And then
wouldn't it be
-5? So those are your two answers that if you plug into either this equation, laser pointer, either this equation or this equation, and I don't care if you plug in a 3 or a -5, in either case, what's your final answer going to be?
0.
0, definitely. X squared plus 2x minus 15. Let's just try it. X squared, did I say plus 2x minus 15?
X squared plus 2x minus 15.
Okay, let's just do it. Actually, you try. So x is right there, and then the square button's right below it. Plus 2x.
Where's the plus?
I know it's hiding.
Oh.
Right there. Minus 15. And we said 3 and -5. So I know that doesn't show the -5 right there, but what's right between -4 and -6? -5. And then what's right between 2 and 4? 3. Feel good about it?
Mm-hmm.
These are called parabolas, or smiley faces, unless they're upside down.
Yeah.
Then they're still parabolas, but they're no longer smiley faces. Super helpful. This is like how gravity works. Every time you plot a graph of a ball flying through the air, it's going to travel in the path of one upside down parabola because it's doing this, right? Gravity acts in a squared fashion. We'll call it a parabolic fashion here.
Mm-hmm.
So anytime you do any equations with anything that moves, cars, planes, rockets, I don't care, literally doing aerodynamics for like making baseballs and whatever, you're going to be using these types of equations, and you're going to want to solve for zeros. A zero in terms of like a ball falling is pretty helpful. Say we have some dude standing on a cliff here. Here he is. Okay. He throws a ball. It does this. Of course, the parabola doesn't extend into the negative direction because time doesn't just go backwards. But as he throws it forward, finding that 0 will tell you how far away from his starting position in the x direction that it traveled. And you're like, cool, whatever. I promise you it's helpful to a lot of people. All right, it is 4:48. We got 12 minutes left. We should probably do a couple more of these while you're feeling okay about it. And this time I won't show you the beginning step, so it is a little trickier. This sometimes takes high school students 2 whole years to learn. So if you're starting to feel like you get it, it means you probably already learned it-ish once. You're practicing it today, and then as we continue to practice, it'll be easy. All right. Gotta hide it from you. Let's see here. How about... All right, this one's going to be, actually, We probably have time for 2 more problems, so make it a little easier. I'm gonna give you some unpressured time to think while I go fill my water. Okay, and remember, there could be other factors of 28 too.
Oh, so that's wrong.
No, I'm just saying there could be other factors of 28, Sylvia. Okay? There also could not be, but there definitely is. I'll be ready.
Is 4 times 7 28?
4 times 7, let's count it 2 ways. 4, 8, 12, 16, 20, 24, 28. Or 7, 14, 21, 28. You weren't in here just spitting obscenities to the camera, were you?
No.
Okay. Y'all find out. Okay. There we go.
I made 2.
Look at
I
this.
don't know if that one's right though.
All right, let's check it. So you got, well, how about we just check it visually first before we even go through the math? Okay, so we have x squared plus 11x plus 28. It's on you. X squared plus 11x plus 28.
Oh,
Yeah, and it's the red graph in this case. So where does the red graph cross? -4 and -7. So we know that's our correct answer. Now let's go back and see why. So what you don't need to do every time is something you did on the last problem to check yourself. But if you ever are confused, a good thing to do is just to FOIL. Because then you'll know here x and x makes x squared, 7 and 4 makes 28. Same here, x and x makes x squared, 14 and 2 makes 28. That's great and all. Now we have x times 7, which is 7x, and 4 times x, which is 4x. So if we add 7x's to 4x's, how many are we going to get?
Add?
Yeah, we're going to add, this is, I'm just doing the foiling out loud. I could be writing it down. Probably should be, honestly.
11.
11, right? So that's what we're going for. Here, x times 2, that's
2x.
2x's, and then 14 times x.
14x.
And what is 14x's plus 2x's?
16x.
16, and maybe if I did that, we'd be good, right? But we would know that basically when you're doing these factors down here, you're always going to choose the factors that can add or subtract together to make the middle term, exactly. The middle term, or just the, we'll call it just the solo x, right?